Hi, everybody. I'm going to see if I can go through these problems for you and try to make them a little easier. And I'm going to also try to teach you how to read a word problem. Let's start with number one. What is an angle of elevation? Elevation means going up. Wherever we are, we're going to be looking up. And that's exactly what Casey's doing. If I was to draw that triangle without the lighthouse and without Casey, this right here, this angle right here, is the angle of elevation. We know that the lighthouse from the top to the bottom is 84 feet. That's how tall the lighthouse is. We know the angle of elevation is 58 degrees. That goes right here. 58 degrees is that angle. We also know this is a right triangle, which makes it this angle 90 degrees. And if Casey is 6 feet tall, straight across, from here to here is 6 feet. This is obviously not drawn to scale. That means 84 minus 6 equals 78 feet. And that's the height of this. What we're trying to find is how far is he standing from the base of the lighthouse, which is this value right here, and I'm going to call it x. Now we have a bunch of trig functions. We have SOHCAHTOA. Sine is opposite over hypotenuse. How do I know if something is opposite? I come stand on my 90-degree angle. And if I'm standing here and I look out, that's opposite. But I'm really not looking for the opposite of that. We really want this 58 degrees. If I'm standing on this angle and I look across, that's opposite. Adjacent means next to. I have two sides next to my 58-degree angle. I have this side, I have this side, and this side. Those are adjacent, but we never call the hypotenuse adjacent because we have another word for that, hypotenuse. Sine is equal to the opposite over the hypotenuse. Therefore, we can't call the hypotenuse the adjacent. The cosine is equal to the adjacent over the hypotenuse. And the tangent is equal to the opposite over the adjacent. Well, we know pretty much everything we need to know. I know here that I have opposite. Remember I said this was opposite. I have opposite, and I'm trying to find adjacent. This right here is opposite our angle, and this x is adjacent. If I have opposite and I want to find adjacent, then I am going to use my tangent function. And I'm going to write it as the tangent of 58 degrees. That's the angle I'm using to find my opposite and my adjacent, is equal to the opposite, which we said was 78, over the adjacent, which we said is x. Now, the first thing I always like to do is not have a denominator or a variable in my denominator. I can always multiply both sides by x. And if I do that, this x cancels with that x. And now I have x times the tangent of 58 degrees is equal to 78, and that's in feet. I can divide both sides by the tangent of 58 degrees. Once I put that in my calculator, I have everything I need. Because here, notice, I have x equals 78 over the tangent of 58 degrees, which equals 78 divided by, and there's no way to find the tangent of 58 degrees except using your calculator. And that is 1.6. Now I'm going to say 78 divided by 1.6, or you could divide by the tangent of 58 degrees, whichever you like. And that equals 48.75 feet. Which means that Casey is standing 48.75 feet away from the base of the lighthouse. The angle of elevation, which means I'm looking up. The angle of elevation from a kicker's foot on the football field to the top of the goalpost bars is 17 degrees. If this is my kicker and he's kicking a football, and then the goalpost is down here. And from my angle of elevation is from my foot now to the top of the goalpost, because right here it says from the kicker's foot on the football field to the top of the goalpost is 17 degrees. I'm going to draw in my triangle. It's going to go to the bottom of the goalpost, and my angle of elevation is 17 degrees. Next sentence. Notice I'm reading it really slowly and making sure I can actually picture what's happening. If he is standing 131 feet from the base of the goalpost, that's 131 feet. How tall is the goalpost? What we're trying to find is this height. And again, I'll call it X. And do I need a goalpost there? Not really. I can just draw a triangle. Here, my triangle has, this is 131 feet. This is what we're trying to find. And we know this is 17 degrees. And of course, I always want to make that 90. This is the opposite. And this is the adjacent. Opposite is across. Adjacent is next to. That means next to the 17-degree angle is 131 feet. This is the adjacent. This is across. This is the opposite. And again, if I have opposite and I have adjacent, I have tangent. The tangent of 17 degrees, which is equal to opposite over adjacent, is equal to, well, opposite is x, adjacent is 131. And now this is what I have to solve. The tangent of 17 degrees is equal to x over 131. Now I can multiply both sides by 131 because I want to get rid of my denominator. And if I multiply, this is really over 1. This cancels with this. And over on the right-hand side, I just get x. On the left-hand side, I get 131 times the tangent is 17 degrees. And now again, I have to take out my calculator. X is equal to 40.05 feet. What does that mean? How tall is the goalpost? The goalpost is 40.05 feet. I just have to figure out what parts I have. Do I have opposite? Do I have adjacent? Do I have a hypotenuse? Leah's mom is standing at the bottom of the slide at the playground, waiting for Leah to slide down. I have a visual. This is Leah's mom over here. The line is the slide, and Leah is at the top, ready to come down the slide. Angle of elevation from the bottom of the slide to the top is 46 degrees. I always make a right triangle, and that's 90 degrees. Now let's see what other information they give us. I've used this. Slide has a vertical height of 9 feet. Vertical is up and down. A vertical line would look like this. Horizontal, think of horizon, across, and it would look like this. Now we know what vertical is. Now we know what horizontal is, which means that the slide has a vertical height of 9 feet. This is 9 feet. Find the length of the slide. All right. This is different. So we want to find the length of the slide. And right here, this is the length of the slide. Now we want to find our hypotenuse. What are we being given? If this is my angle, then I look across and I have 9 feet. So I have the across, which is the same as opposite. And I have the hypotenuse. Hypotenuse is always the longest side, and it's always across or opposite of the 90-degree angle. If I have opposite and hypotenuse, that's sine. So, SOH, opposite over hypotenuse. The sine of 46 degrees is equal to the opposite, 9, divided by the hypotenuse, which I don't know. Let's call it h. Again, first thing, I'm going to get rid of my fraction. I'm going to multiply both sides by h. This gives me h sine of 46 degrees is equal to 9. The sine of 46 degrees is a number. I have to get it out of my calculator, but it still is a number. That means I can divide both sides by the sine of 46 degrees. And that gives me h is equal to, why is that h? Because this cancels with this. H is equal to 9 divided by the sine of 46 degrees. And that value from my calculator is 12.5, round to the nearest tenth, 12.5 feet. And that is the length of the slide. And that's it. We found the length of the slide. All you really have to do is think of SOHCAHTOA. SOHCAHTOA, which says that the sine is equal to the opposite over hypotenuse. Cosine equal adjacent over hypotenuse, and tangent is equal to opposite over adjacent. And you really need some angle here. That's a Greek letter called theta, and we're just going to say that is our angle of elevation for these problems. Okay, I have one more. And really the first thing you always want to do is draw a picture. A dog is standing 5 feet from the base of a tree. This is my tree, and my dog is, okay, there's my dog. And the distance from here to here is 5 feet. Looking up at a cat that has climbed 16 feet up in the tree. Here's my cat in the tree, which means that the dog is looking up at the cat, and the dog is 5 feet from the tree. I have a triangle. I'm going to take my picture and I'm just going to make a triangle. It's a lot easier to see with just a triangle. I know this is 5 feet. And so far, that's really all I know. A dog is standing 5 feet from the base of the tree. We did that. Looking up at a cat that has climbed 16 feet up in the tree. This distance is 16 feet, which means I know that. We're trying to find the angle of elevation from the point the dog is standing on the ground to the cat. We have our picture. We know this, and I'll just call it X. This is the angle of elevation. Let's start with, what do I know? I know the opposite over the adjacent. Why is this adjacent? Because it's next to that X value. 16 feet is opposite. I'm looking across. I'm looking out from the angle, and what I see is the tree. And now, since I know I have SOHCAHTOA, TOA is the one I need, because that's tangent equals opposite over adjacent. Therefore, I have the tangent of X is equal to the opposite over the adjacent. And what we need to do is find X, but X is actually inside the function. So I can't just take it out. I can't divide by X. Now all I have to do is I have to find X, but these are not multiplied. This is a function, which means I have to use the function that cancels out tangent, which is inverse tangent. And if I take the inverse tangent of both sides, the property that it has, the inverse tangent of the tangent cancel, and I just get X is equal to the inverse tan of 16 over 5. And the inverse tan of 16 over 5 is 72.6. What do we want to round to? The nearest tenth. Then we've done it. Tenths are 1 decimal place. And that's my final answer, 72.6 degrees. And that's all I'm doing, is I'm just figuring out how to make a triangle. Now I'm going to look at the angle of depression. You could say when you're depressed, you're down. The angle of depression is always from somewhere I am looking down. And let's see what we have. A lifeguard is sitting on a platform looking down at a swimmer in the water. If the lifeguard's line of sight is 8 feet above the ground and the angle of depression to the swimmer is 18 degrees, how far away is the swimmer from the lifeguard? Now, this works a little different. Let's again make our triangle. Everything we do that we can make a triangle makes it a lot easier when we're doing trigonometry. If the lifeguard's line of sight is 8 feet above the ground, the line of sight is 8 feet above the ground, which means that this is 8 feet. The angle of depression to the swimmer is 18 degrees. Now, this is a little different. I'm actually sitting up here at the top, aren't I? When I look down, this is the angle of depression. If the angle of depression is 18 degrees, and I also know that this right here creates a 90-degree angle. And if I have a 90-degree angle, that means that this angle of 18 degrees plus this angle has got to equal 90 degrees. 18 plus, that's what we're trying to find. I'll just call it x. That equals 90 degrees. I subtract 18 degrees from both sides. This cancels and I get x equals 72 degrees. So now I know this angle is 72 degrees, which really helps me because this angle right here is 90. And if that angle is 72 and that angle is 90, I assure you this angle also is 18 degrees. How do I know that? If these are parallel, which they are, then alternating angles would be on different sides of the transversal. This is the transversal. That means that this angle equals this angle, which is really what we're doing here. Those are alternating interior. They're alternating because they're on different sides of the transversal. They're interior because they're between the parallel lines. And alternating interior angles are always equal to each other. I don't even need that 72 degrees. I could just erase this. Erase this. I know that that is 18 degrees. That's the angle of depression, which means that this angle right there that I have the other 18 is also 18 degrees because of my transversal. How far away is the swimmer from the lifeguard? Well, here's the lifeguard. The lifeguard's looking at the swimmer. So the swimmer's over here. And I want to know this distance. And again, I can call it x. That's how far away the lifeguard is from the swimmer. I have opposite over adjacent, which is again tangent. Tangent of 18 degrees, because now I know the angle is equal to, now we are at that the tangent, because we have the opposite, which is right here, and we have the adjacent, we need the tangent. Tangent of 18 degrees equals opposite over adjacent. Now, I'm going to multiply both sides by x. I do that because I want to cancel the denominator, which means I now have x tangent of 18 degrees is equal to 8. And the tangent of 18 degrees is just a number. I can divide both sides by that number. The tangent cancels. I end up with x equals 8 divided by the tangent of 18 degrees. And now I get out my calculator. X equals 24. Now we have to figure out what we want to round to the nearest tenth. You always want to look to see what you want to round to. I want to round to the nearest tenth. I have 24.6214. The nearest tenth is the 6. I look 1 to the right. Because it's a 2, I just get rid of everything. If it was a 5 or more, I would have to round that 6 up to a 7. My answer here is 24.6 feet. And that's how far away the swimmer is from the lifeguard. Notice the directions always say draw and label a diagram, then solve for the missing part, because you have to kind of see what's happening. Here we have a pilot in a helicopter, spots a landing pad below. Here's my pilot. The angle of depression, remember? First, I'm looking out. Just like on the angle of elevation, I first made a line from myself to the object. That's what I'm doing still. I'm making a straight line because I need a right angle. And here is part of the triangle. And then we have the ground. He's above the ground, so I need my right triangle. Once I do that, the angle of depression is 73 degrees. That means this angle is 73 degrees. I also need to make the rest of my triangle. The horizontal distance to the pad is 1,200 feet. Here's the pad. Here's the pilot. The horizontal, remember I just talked about horizontal, is 1,200 feet, is right here. What is the altitude of the helicopter? I'm trying to find this. Altitude means how high it is above the ground. I also learned that if that's 73 degrees, this also is 73 degrees. I showed you in the last problem how you can use two parallel lines with a transversal, or if that's 73 degrees and we have a right triangle here, that would make this 17 degrees. And if that's 17 degrees and this is 90 degrees, then the other angle is 73 degrees. Let's find out what we're trying to solve for. What is the altitude? That's my x. I want to solve for x. What do I know? I know adjacent. This is the angle that I'm using, which means that this is the adjacent. The opposite is always across. Imagine you're standing here and you're looking out. What would you see? You would see this X line. This is opposite. When we have opposite over adjacent, we need tangent. I have the tangent of 73 degrees is equal to the opposite x divided by the adjacent 1200. I multiply both sides by 1200. That will cancel that. I have 1200 times the tangent of 73 degrees. All I need to do now is get my calculator. This becomes x, and with my calculator, and I get 3,925, and round to the nearest tenth, it is 0.023. Because it's 0.023, it's actually exactly this. The 0.023 just goes away when I round. So the answer is the altitude of the helicopter is equal to 3,925 feet above the ground. Again, we have angle of depression. Let's read the question. Building A is 480 feet tall. This is building A. Building B is bigger. It's 654 feet tall. If the angle of depression from the top of building B to the top of building A is 42 degrees. Remember, angle of depression is this angle right here. I can then make my triangle. If this is 42 degrees, what else is 42 degrees? Hopefully you said this. That angle is 42 degrees. How far apart are the buildings? What do I know? What do I need to know? I need to know how far apart the buildings are. Let's call this X. I don't know the length of the hypotenuse, but I can figure out this distance because there's my triangle. That distance is going to be 654 minus 480, the height of one building minus the height of the other building. That equals 174 feet. We can redraw a triangle if we want. Maybe we'll do that to make it less confusing. I have an angle here of 42 degrees. I have a height here of 174 feet. I want to find X. If I'm standing here, my opposite is across. My adjacent is next to. Since I have opposite and adjacent, I have to use tangent. The tangent of 42 degrees is equal to the opposite, 174, over adjacent. Now I solve. Multiply both sides by x. Cancel, cancel. I have x tan of 42 degrees equals 174. I divide both sides by tangent of 42 degrees because what I want to do is get x by itself. I want to know what x equals. The tangents cancel on this side. I end up with x equals 174 divided by the tangent of 42 degrees. And now it's time for my calculator. That becomes 193. Then let's look to see round to the nearest 10. You really always want to find out what you want to round to. So this number becomes to the nearest 10th, 0.2 feet. And that is the distance between the buildings. And that's it. We have one more problem. Zach is standing at the top of a lookout tower. So we have a tower. And this is, and spots a water fountain below. If the lookout tower is 75 feet tall and the angle of depression is 28 degrees, And remember, I'm always thinking about my triangle. This is going to be my triangle. What is the horizontal distance between Zach and the water fountain? We're trying to find horizontal distance. That's X. And again, we can use either the transversal or we can use the fact that a triangle has 180 degrees to find out that this also is 28 degrees. Let's see what we have. Let's see what we need. We have the opposite. We have the adjacent. Again, we need tangent. We have the tangent of 28 degrees is equal to the opposite over the adjacent. Again, I multiply both sides by x. I get x tan of 28 degrees is equal to 75. I divide both sides by the tangent of 28 degrees, which gives me x equals, again, calculator, 141 point to the nearest 10th, 0.1. And that is in feet. That's the distance from the tower to the water fountain. And that's everything. Thank you so much. Have a good day.